Today we're going to be talking about how to find the supremum and infimum of a set, any sort of arbitrary set. Specifically today we're going to be talking about intervals. So we're going to go into an example pretty quick. Before we get into the example though, we're going to give some context for what the supremum and the infimum is of a set though. So if we talk about the supremum of a set A, we're talking about the least upper bound for the set A. And then when we're talking about the infimum of a set A, we're talking about the greatest lower bound. So the example we're going to be doing first is this. The set A is equal to the interval from 1 to 4. There's a definition in real analysis that says the right endpoint of a set is the supremum of that set. So we go over here and we look here. Well, the right endpoint of the set is here. It doesn't matter that the right endpoint is open from this round bracket. And similarly with the infimum of the set A, the infimum is the left endpoint of the set A. Notice how this is a closed left endpoint, but regardless, they're still endpoints. So the proof goes like this. I'm just claiming here that I believe the supremum of A is 4 and the infimum of A is 1. Left endpoint of A, infimum of A must equal 1. Similarly, I'll write that, similarly, since 4 is the right endpoint of A, supremum of A equals 4. And then those are the only things you have to say. You're done your proof now. Okay, the second example we're going to do is also an interval, but it's written in set notation. What we have to do is convert this into an interval. So the way to do that is look at what it says. A is the set of all real numbers such that x is less than 4. So what this is saying is this. This set is equal to the interval from -infinity to 4. Okay, the reason why we put an open bracket here is because -infinity is not included in the real number set, so we have an open endpoint there. Similarly, with the right endpoint, if we look at the set notation, it says x is less than 4. If it were to say x is less than or equal to 4, then we would have a closed bracket. However, because it's less than 4, the number 4 is not in our set A, which means that we have to have an open bracket. So we're going to write it like this. And then now you can basically just follow what we said about the first example, and we're going to write the proof the same way. So let's go do that. Same thing again, I'm going to claim that the infimum of A is the left endpoint. What's the left endpoint here? -infinity. Similarly for the supremum of A, I'm going to claim that it's the right endpoint of A. What's the right endpoint of A? 4. So I'm going to say claim the supremum of A equals 4 and the infimum of A equals -infinity. Okay, I just wanted to put a little cut in the video to say that when I was calling the infimum of A -infinity, I did that so I could show you that you don't want to exactly copy the first example, because you'll see at the end of the video that the infimum of A is actually not -infinity and it actually doesn't exist. So this is an example where you can't just assume every example is just the same as the last. You have to think a little bit harder and look at your definitions and theorems. And then we go write our proof like this. Since 4 is the right endpoint of A, sup A equals 4. Similarly, since -infinity is the left endpoint, but wait, when we're talking about the intervals that have infinity and -infinity, There's also a definition in real analysis that says if the left endpoint or the right endpoint of a set is infinity or negative infinity, that side of the interval does not have an upper or lower bound. So actually, in this case, we can say that there is no infimum of A because there is no lower bound. And a lower bound is just anything that's less than or equal to the left endpoint. And I don't know any number that's less than or equal to minus infinity because it's minus infinity. So we cannot write this. We have to say something different. Since minus infinity is the left endpoint of A, negative infinity is still the left endpoint. However, we just don't have lower bounds, which means we don't have an infimum because I'm not able to find a number that's less than or equal to negative infinity in the real number set, which makes sense because negative infinity itself is not in the real numbers. So I simply just say that the infimum of A does not exist. The infimum of A does not exist. And this would be the same case if you had a right endpoint that said infinity. However, you would say that the supremum of A does not exist because infinity would be the right endpoint.